Hi everyone, this is a tutorial on how to create a pixelated shader with some color banding. So this is an example of what you can make within 5 minutes of watching this tutorial. If you just want to see the nodes from the finished result, then here you go, have fun, but I will be going through all of this in detail. So first of all, this type of shader is used in a post-processing volume. So in your scene, you want one of these post-process volumes. So if you don't already have one, you can go here, add a post-process volume, and then you want to search for extent and tick infinite extent so that it applies to your whole scene. And then what we're going to do is add a post-process material. So first of all, let's make that material, and let's call it something like mpixel shader. Let's open this, close my other tab, and the first thing we want to do is select this output node, and we'll change it to a post-process material, so we just have the emissive color. And the first thing we want to do is get the screen position, so we get the viewport UVs, and then from the UVs we can multiply by dragging out and pressing M, multiplying by scalar value by pressing out, dragging out and pressing 1. We can change this to a parameter called pixels, and this is the wrong way of doing it. This is what most tutorials will teach you. So I'll teach you the sort of correct way later, but let's see why this is the wrong thing to do. So let's set this to something like 256. And then what we want to do is use a floor node and then divide it by the same factor again. So divide by the number of pixels, and we'll plug this into a scene texture. And whilst you've got the scene texture selected, go ahead and select post-process input 0. So let's apply this, and we can see that it is now a little bit pixelated. To make it more obvious, I'll set this to 128. You can see this is indeed pixelated. So let's go to our game. Let's create a material instance by right-clicking, selecting create material instance. Name it whatever you want. Let's say MI pixel shader. Whatever. And then you can open it up, create a little window, and with it selected in your editor, you can select your post-process volume, search for materials, add a material to the array, choose asset reference, and we can select this little button to populate it with our material instance. And so now you can see it has indeed worked, but there's something wrong about it. And I don't know if you've noticed, but if you look at each of the little pixels, they're all rectangles. They're the same aspect ratio of your screen itself. So whatever your viewport aspect ratio is, that's what the pixels will look like. So if I were to sort of change the size of this, you'll see the pixels do become more square. If I make it really ridiculously long, the pixels will become long as well. So the way to fix this is to use the screen resolution. So let's minimize this, go back to the material, and what we can do is, instead of multiplying by the number of pixels, we can do something slightly more clever. So screen resolution, and we can divide our screen resolution, which will be something like 1920 by 1080, divide that by a factor. So let's do a scalar parameter. Let's call this number of divisions, and let's set this to 4 to begin with, and then we can plug this into where the pixels parameter is currently plugged into. You can get rid of that. And so now, with a really simple 30-second change, we have square pixels. And just to make that really obvious, let's get our material instance and turn up the number of divisions. So you can see each of the pixels is indeed a square rather than a rectangle. Now we can improve this even further. You'll notice that if I sort of have this viewport angle, if I create it, if I make it really pixelated, you'll see it kind of focuses in on the top left of the screen, and that might seem really picky if you have a very low pixelation shader. You won't really notice the effects too much, but if you kind of focus on the position of this blue cube, as I increase the number of divisions, you can see the cube slightly shift down and right, and there is a good reason for this. It's because we're using the floor node in the material graph. So instead of using floor, we could either use round instead, or we can divide by the ceiling. We can average between the ceiling and the floor. So we can do floor and ceiling, add them together. Let's move these over. And let's divide by 2. So now, when we apply and then go back to the scene, if we adjust the number of divisions, the blue cube actually stays in the same place. There's no sort of movement. So you know that the pixelated representation of that object is actually accurate to the position of the real world object. It's a very minor difference, but if you have quite a pixelated game, it does make a difference to where you think the object is to where it actually is. And as a little bonus, let's also do some color banding. And again, this isn't necessarily the absolute best way that you can do these things, but it's a really quick and easy way to get good results. So out of the scene texture node, we will desaturate the color first. Let's multiply this, and in fact we're doing the same logic as what we did here, so we can just copy and paste this. So let's plug this all in, and then we need to make sure we're dividing and multiplying by the same factor. So let's create another scalar parameter, convert it to a parameter, and let's call this colors, and let's set this to 5. We can then plug that into the final node, and I forgot to do something. So this is the desaturated version. What we want to do is average this with the actual color from the post-process input. So let's add this together with the desaturated version and divide it by 2. Then plug that in. And you can see we get the original color back, but now it's got these color bands. So let's apply this, save, and go back to our game, and let's look at how that new parameter affects our scene. So we'll slightly decrease the number of divisions just so we can see a bit more clearly. Let's change the number of colors. So the higher the number, the more sort of normal the colors will be. But as we decrease the number of colours, you can see there's some bands starting to happen. If we take it really low, you get real banding. So yeah, set it to whatever you think looks good. I tend to like sort of 8, I think, is a nice effect. But it really depends on your game. And I like 4 for the number of divisions. So yeah, that's basically how you set up the nodes, but I haven't really explained why this works, and I thought I'd leave this mathsy bit to the end just in case anyone's interested. So your screen position, what I would really recommend doing if you're wanting to learn how to make shaders is think about each of these things as like a vector that you're manipulating. So the screen position is like a 2 vector, so you've got the X position and the Y position of the screen. And if we do a preview node, you can see exactly what it's doing. So the entirety of the screen is being represented from 0 to 1 and from 0 to 1 going left to right, up to down. So at the very top left, that's a 0, 0, bottom right is a 1, 1, top right is 1, 0, bottom left is 0, 1. And so what you're doing when you're multiplying and then doing these operations is you're multiplying out this screen multiple times larger than the actual viewport. And then you're truncating it so that you're creating individual pixels, that number of pixels that you multiplied it by. And then when you divide it back again, you're making sure that it's the right size for the viewport. And then you're using those new UVs to color your scene based off the post-process input. So you're plugging your new UVs into here. And those new UVs will be discretized versions of the UVs that you see here. So we can actually preview this, and you'll see what I mean. So I've turned up the number of divisions, let's say to 32, and you can see each of the little pixels. So each of these will be the same color. So each of these is pointing to a single coordinate within this like post-process image. And so then with the color banding, what we're actually doing is discretizing the light intensity. So by desaturating the color output of the post-process input, basically when we desaturate something, we're changing the RGB values to whatever the highest of those values is. So currently green is 0.7, that's the highest. So if we were to slide the saturation all the way down, you can see that all of the RGB values become the same. And if these were all lower, it would be generally darker. If these are higher, it's lighter. So we're looking at each of the positions of the pixels, and we're looking at what color they are, deciding how light they are, and then by doing this kind of multiplication, truncation, and then division, we're discretizing the light values. And then to get color back into the scene after desaturating, we're just averaging with the original color from post-process input. So hopefully that sort of makes sense. Let's preview this and see what it looks like. So we saw this before. This is just the light values in a sense. And if we were to turn this down a lot, you can see that it's, with two discretized down to two different colors, it's basically a black and white image. If we turn this up to, let's say 12, we've now got like 12 different color bands for light intensity. So then that creates the image that you see here. I just thought of another explanation that I can use this viewport UV stuff, which might make slightly more sense. If we were to take a screenshot of this viewport, so let's say this is our viewport. What we're doing when we look at the UVs is we're actually looking at a sort of unit square version of the entire screen. So here the UVs go from the top left 0, 0 to the bottom left 1, 1. And then if we multiply by a factor, let's say by 8, let's increase this. So that's, there we go. So when we multiply, we're basically multiplying this by whatever factor. So let's say this is roughly 8. We're increasing this. And then what we're doing is we're saying that original unit square size, we're, say if we took like the floor node, we're saying that anywhere within this pixel size, we'll just go with whatever color is the top left of that pixel. And then we'll go to the next one. Whatever is the top left of this little square, we take that color, and we so on and so on, so that once we then shrink it back by dividing, and then eventually plugging it into the UV, to the scene texture UVs, you'll have your new pixelated screen. Anyway, thanks for watching. I was a little bit longer than I expected and a bit rambly, but if this was actually helpful, please leave a comment and I can put more effort into the next videos that I do. Yeah, thanks for stopping by. See you next time.